Imagine you have 50 microservices. Each microservice needs authentication, needs rate limiting, needs logging, monitoring, and access control. That's 50 places to implement the same security code. 50 places where something can go wrong. This is where API gateway comes in. An API gateway is a single entry point for all your backend services. Think of it as a reverse proxy with superpowers. Every request from the client goes through this API gateway, whether it's mobile, web, and third party. The gateway then routes requests to the correct microservice. But routing is just the beginning. The real power is what happens in between. Let's trace a real request to the gateway. Step 1. Client sends a request to api.example.com/orders. Step 2. Gateway receives it and runs a pipeline of checks. Is this request authenticated? Is this client authorized for this endpoint? Has this client exceeded their rate limit? Which backend service handles /orders? Step 3. If all checks pass, gateway forwards the request to the order service. Step 4. Order service processes and returns the response. Step 5. Gateway adds response headers, logs the transaction, and send it back to the client. All of this happens in milliseconds. Rate limiting protects your backend from overload. The most common algorithm is token bucket. Here is how it works. Each client gets a token with 100 tokens. Every API request costs 1 token. The bucket refills at 10 tokens per second. If you make 100 requests instantly, your bucket is empty. Request 101, rejected with 4 to 9 too many requests. Wait 1 second, you get 10 more tokens. The gateway tracks this per API key, per endpoint, or per API address. For paid tiers, you might get 100 tokens per second. For free tier, maybe just 10. Authentication. Who are you? Authorization. What can you do? The gateway validates both before routing. Common authentication methods. API keys. Simple, but if leaked, anyone can use them. JWT tokens. Client logs in, gets a signed JSON token. Every request includes this token in the header. Gateway validates the signature without calling the auth service. Auth 2. For third-party apps accessing your API, log in with Google or Facebook, that's OAuth. Authorization checks happen after authentication. Your JWT might say role user, but the endpoint /admin/lead requires role admin. Gateway blocks it there itself. 403 forbidden. This means your microservice don't need to implement auth. They trust the gateway. Access control is more granular than just authentication. If IP whitelisting, only requests from a specific address can access /admin. Time-based access, API only available 9 a.m. to 5 p.m. Geographic restrictions, block all requests from certain countries. Client-based quotas, free tier gets 1000 requests per day. The gateway enforces these policies before routing the request to the microservice. If you are not on that IP range, blocked. When a request touches 5 microservices, how do you debug failures? This is where distributed tracing comes in. The gateway generates a unique trace ID for every request. This ID is passed to every downstream service in the headers. When you look at logs, gateway logged it, auth service logged it, order service logged it, payment service logged it, all with the same trace ID. Now you can reconstruct the entire request path. Tools like Jagger and AWS X-Ray visualize this as a timeline. You immediately see order services is the bottleneck. Single point of failure. Here is the scary part. If your API gateway goes down, everything goes down. It's called single point of failure. How do we solve this? Multiple gateway instances. Run 3+ gateway instances behind a load balancer. If one dies, traffic routes to the others. Auto scaling, traffic spike, launch more gateway instances automatically. Health checks, load balancer pings each gateway every 5 seconds. Unhealthy instance removed from rotation. Multi-region deployment, deploy gateways in US East, West. If an entire AWS region goes down, traffic fails over. Circuit breakers, if a backend service is failing, the gateway stops sending requests, returns cached response or a friendly error instead of errors. This architecture means no single instance is critical. System survives instance failures, system survives region failures. Now look at a real example. Let's look at a real implementation. AWS API gateway. You define your API with routes get/users, lambda function get users handler, post/orders, lambda function create order. AWS handles HTTPS termination, request validation, rate limiting, CloudWatch logs for every request, integration with AWS WAF for DDoS protection, and you pay per request. No servers to manage, it is a fully managed service of AWS. To recap, API gateway is your single entry point that handles multiple things: authentication, authorization, access control, logging, distribution, tracing, high availability. It's the security guard, traffic cop, or bookkeeper for your microservices. Should you use one? If you have more than 2 backend services, absolutely. Want to build your own? Check the description for architecture patterns. Need help designing your API gateway strategy? Email us. Email is on the screen. Subscribe for more deep dives every week. Thank you.